let us start this module by discussing the different building blocks that make up an autonomous vehicle. Okay. So, the level of autonomy is actually well defined in the standards. So, the highest level indeed is that there is no more steering and there are just humans sitting inside and the vehicle is moving all by itself. If you have to build a complex system like that, you have to break it down into manageable parts first, right, and you have to look at module by module, manageable unit by unit, get into the detail of each one of these units and understand its linkages to other modules and other subsystems which make up this complex vehicle. So, it is not that autonomous vehicles or anything has happened overnight, never. In fact, the level at which engineers have been working, particularly automotive companies and engineers in them have been working is dates back to 1970s, where they said that autonomy is a very important aspect of replacing mechanical or I would say even hydraulic systems with electronic units, with electronic modules. This is already the start of going towards building autonomous vehicles. This is the most important thing you have to bear in mind, which clearly indicates that the hardware components and the possibilities. So, look at what happened with respect to hardware of electronic modules, the software, okay, that makes up the whole electronic system has become very complex functions which this software can do, particularly to improve comfort of the vehicle, okay, of the vehicle. It is something that and so a vehicle not only, I mean when I say software, comfort of the vehicle's occupants basically, of people who are sitting inside, and assisting driver to control the vehicle through several functions. So, this electronic modules have assisted, this hardware modules have assisted even the driver, right, driver assisted, driver assisting, I would say driver assist through several functions like steering, traction and so on. So, all this have been happening for quite some time, and the way the things are progressing, you can see that even braking has moved, right, even braking. And nowadays you have very modern cars where we talk about ABS, you say anti-lock braking system is around now, electronic stability program is around, then you have electric power steering, right, it is already there. Active suspensions, these are around now, and also many parts of engine control. Okay. Now, this is critical because it has improved fuel efficiency. All of this is actually leading to building these autonomous vehicles, semi-autonomous to fully autonomous. So, I would say the highest level is indeed the autonomous vehicle, fully autonomous vehicles, and different gradations which allow you to different levels of autonomy that you can bring in. So, when you say ADAS, you actually mean advanced driver assistance systems, advanced driver assistance systems, driver assistance systems is also called ADAS, right, which are basically systems that help the driver in the driving process. So, when you look at the whole system, You will be actually wondering it is all about human and the machine and a nice interface between the human and the machine, which if done very nicely, in fact many systems have implemented this successfully, you basically increase the safety. You actually increase the safety and also not only safety of the car but also safety on the roads when people are so because most of the times it is because of human negligence or human error, I would say human error, that there are accidents. And if machines can do that well, you are that much more better off. Alright, so let us now, I will show you what I actually mean by this by giving you a very simple picture of what has been around for a long time now, not actually very long time but something that people have been talking about for a long time, and that is drive by wire. Actually there is something called drive by X. Many things you can do. Drive by X means X can be replaced with several things, and here we are just talking about drive by wire. Let me give you a very simple feel of what I mean by this. You actually have, this is what, this is where the leg is sitting, right, and this is your famous accelerator in a vehicle. This is accelerator. This accelerator is connected to, if you now start looking at drive by wire, all the mechanical linkages and all of that which I mentioned previously here. For instance, I mentioned all this mechanical and hydraulic systems being replaced by electronic modules. This is an example. This is actually, it can be a simple position sensor. Okay. In fact, it can even be a potentiometer. Potentiometer. Already it is an electronic component. This one can be connected to the engine control module. This can be connected to the engine control module. This one in turn will connect to the engine. You know, inside the engine is this butterfly valve, right, butterfly valve. This is the one, this is a motor, okay, this I will call this as a motor. This ECM is connected to this motor. This motor in turn is connected to this butterfly valve. So how to imagine this butterfly valve? If you have not seen one and if you are not electronic engineers, this is a pen cap. Okay. Inside this pen cap, supposing I put a disc, which is exactly the same diameter as this pen cap, exactly the same diameter as the this pen cap. This fellow here, this guy is the motor, call this the motor. Actuator, this little clip that we put here can be regarded as a clip. Now supposing I connect this clip to that disc and I lift this, what will happen? From a vertical position it will go to some angle and settle down, right. So essentially the more you lift, the disc inside will start becoming more horizontal. It goes from a vertical position to a horizontal position. In a very simple way, that disc inside is nothing but the butterfly valve. The amount of opening will depend on the amount of airflow. As the airflow increases, the fuel that has to be injected for mixing air, right, with the air will also have to increase, and when you do more airflow and more fuel, what will be the power? The power will be much higher. So it will be going at a much faster speed. So how do you increase the speed? So you keep pressing the accelerator, and that in turn will do all of this by opening this butterfly valve, allowing more air and more fuel and mixing. Optimal mixing will give you high fuel efficiency. I mentioned this already that this becomes very important. So sorry, I have to come. So fuel engine control, all this is part of engine control. So you need to have very high fuel efficiency. If you want to do that, this mixing of air with fuel is a very important aspect. Of course there is air filter and all that to remove other dust components and all that, that is all one part. But then ultimately it is about mixing the amount of fuel that you feed and the amount of air, they have to be optimally mixed so that the amount of power that you derive from the engine is higher, and then the vehicle can move faster, can move at a much higher speed. All of this can be captured by this little picture. Okay. So you can see that I have put this butterfly valve and there is a motor. Originally all of this, there was no position sensor, there was no potentiometer, and perhaps you would have your leg directly controlling the butterfly valve. You will be opening the butterfly valve directly perhaps, or you may be wiring it to an electronic control module or engine control module sometimes called, which in turn is doing this. So right now you can see what is your ultimate feel, what is the feel you are getting to the leg, nothing to do with this valve at all. No pressure is coming, no return, no feedback is coming from pressing this valve or actuating the motor. You are not getting that feel, it is all wire. This is a wire, right. This is also a wire, this is drive by wire. You are replacing all controls, mechanical and hydraulic, with these wires. Now you may ask, what happens if this wire snaps and will I have a risk and all that. Well, it is not at all anywhere close to what you can imagine, the amount of reliability that the system provides. In fact, you can have problem the other way, that when you press this and you did not have wires and you were actuating this butterfly valve directly, either via the ECM or directly, there is a good chance that this might jam. If this jams, the vehicle is out of control, right. Either it jams by opening more fuel and air, it might simply get jammed in that position and does not come back. When you release your leg from the accelerator, it is supposed to come back, it is supposed to cut speed, does not happen, what will you do? So in that sense, wire based systems are much more reliable. Also you have to note, look at another thing, I have not completed the picture here. Here there is what is known as a throttle, 3HROTTLE, throttle pressure sensor. Okay. This throttle pressure sensor actually conveys the position of this butterfly valve directly to ECM. Now you can see this is input, this is output, this is an output, right. This is an output, of course it is a wire, this is an input. So everything is happening with respect to leg position here. If you press more, something happens and then you get back what is known as the throttle pressure sensor, giving you the position, at what position the valve is. So all of this essentially means if you do drive by wire, you will have the following advantages. You will have the following advantages. Fuel delivery and ignition timing control is accurate. I will not say anything more. It is better, is efficient, much better. Then so fuel delivery, so that is one part. The second thing I mentioned to you is about this, we should know a little more about this throttle pressure sensor. This throttle pressure sensor is used to monitor the throttle position. So what it will do? What will it do? Monitor the throttle, throttle, throttle position, and what will it do? It will convey the position of the accelerator pedal sensors. Okay, so it will convey the position to the ECM, monitor the throttle position and convey the same to the ECM, engine control module, electronic control module. So many names are there which are there. Okay. Then there is also other sensors, I did not put that, but there is also called the map sensor. There is a map sensor. See, these are all part of what is known as in a broad sense it is called the throttle body. When you say throttle body, okay, throttle body will have all these sensors. It will have the TPS sensor, it will also have the map sensor. We will go into a detail of this. The map sensor essentially, so before we go, what is the throttle body? It is nothing but what I mentioned here. This is the throttle body, this is the throttle body where there is a butterfly valve located between the air intake filter and the intake manifold. Okay. So essentially it is this, it is like a small part. So the map sensor is a, it is nothing called the, nothing but the manifold absolute pressure. So it is nothing but the manifold absolute pressure sensor, okay, and this one's job is essentially to sense the engine load. In a way it will sense the engine load. So the sensor what it does is generates a signal proportional to the amount of vacuum, generates a signal proportional to the amount of vacuum in the intake manifold, vacuum in the intake manifold. Okay. So this is another important thing. So what this sensor does is it will give that information to the engine computer, which will then adjust the, I mentioned to you about the ignition timing, right, I mentioned it here. So ignition timing. So map indeed is something that is required along with TPS. So TPS is more like a feedback. What is the position of the butterfly valve will be known to the ECM. It is like more like a feedback. You give a command, ECM gives a command, it will give a command to move, tilt the butterfly valve to some degree. That should happen through this motor. This motor is expected to rotate because it is coupled directly to the valve. Once it moves, that position is recorded by the throttle pressure sensor, essentially that. But this map sensor is the one that will generate give a sense of the engine load, and it generates a signal proportional to the vacuum in the intake manifold. So that the ignition timing and fuel enrichment happens properly. So when I say the advantages of drive by wire, it is because of this fact that the sensors are present. This is the key takeaway from what I was trying to tell you. Also that is one thing. Then as I said, the cruise control part becomes easy now. Okay. So this is one, so fuel, so let me not write it here. Map I finished, right. So I will put map here. So I will simply call this TPS and map. TPS and map put together provide you this advantage of doing drive by wire. The third advantage of doing drive by wire indeed is safety, as I said, cruise control and safety become prime if you do it this way. So now you see what you are driving at, a very complex system where human was pressing something and basically the accelerator, and the engine either increasing its taking a lot more fuel and taking a lot of air and giving you a lot more power, or the other way, all of this is getting now replaced with this drive by wire. Very minute step, very minute, I would say minute step, but a very important step in moving towards autonomous driving. This is the point I wanted to convey, that it has been an evolution from 1970s by replacing all that with all these ECUs. And today a modern vehicle can have anywhere between 70 to 90 ECUs. Okay. You can have 70 to 90 ECUs, 70 to 90 ECUs. And now you may ask, what are they doing? What is the function of these ECUs? Why do you need so many of them, right? You may even ask that. And let me give you an example.